My dear my dear grade 9 learner, welcome to this online session. And in this online session, I can tell you for sure, you're going to learn a lot. You're going to enjoy the lesson. Welcome. We start off, and as we start off, I want to ask you to think about this question. And before that, on your screen, there are some pictures. What do you think is happening? Look at those pictures well and tell me, what do you think is happening? Have you ever seen or heard about a volcano or an earthquake? What do you think causes land to shake or to break? Think through these two questions as we start off this very interesting and very informative lesson. Our topic for today is types and causes of earth movements in the environment. Types and causes of earth movements in the environment. Are you ready to learn? Good. We'll move on. Now, for our introduction, we'll start by defining what earth movements are. Read with me. Movements or shifts of the earth's surface caused by internal or external forces. Earth movements, these are movements or shifts of the earth's surface that are caused by internal or external forces. We continue. And after having defined what are earth movements, let's look at the main types of earth movements. There are two main types of earth movements. The first one being tectonic movements, and the second one is mass movements. Have you ever heard about Pangea? Ever heard about Pangea? Maybe you've heard of it, or maybe you've not heard of it. What's this Pangea? Now, there's what we refer to as the continental drift theory, the continental drift theory. And according to the continental drift theory, Pangea was a supercontinent a long time ago, about 230 million of years ago. And according to the continental drift theory, all the continents were joined together like one big land. Over millions of years, the pieces slowly drifted apart to become the continents that we know today, like Africa, Asia, and South America. And this continental drift theory, the originator of the theory was known as Alfred Wegener. He's the one who came up with this continental drift theory. So now you've known what is Pangea. On your screen, I'm showing you where we started with one supercontinent, which we've referred to as Pangea, over 225 millions ago. Then the continents gradually started drifting far away from each other. And you can see 100 million years ago, they started to separate. 65 million years ago, at least now you can see a clear picture of the current continents that we have. until now, what we have currently with the continents that we know. How did the continents move? So the current theory is that the continents moved due to the movement of the tectonic plates. When I talk of the tectonic plates, these are movable slabs of rock that make up the Earth. And on your screen, you can see a picture of those tectonic plates. What evidence is there for the continental drift theory? You see, for a theory to be tangible, we must have evidence. According to Wigner, he based his hypothesis on several pieces of evidence. The first piece of evidence is when he looked at the shape of the continents, they look like they fit together like puzzle pieces. So this is what we call the jigsaw fit. Like on your right, you can see that picture showing that the continents look like they fit together, all right? So that's evidence. If you look at like South America and Africa, it goes without saying that these two continents were once together. The second evidence is the fossil evidence. The same type of fossils that are found on continents separated by vast oceans. So you find there is a fossil that is found in a continent that is in South America, and the same fossil is found in Africa. And these two continents, they are far apart. So Wegner came to a conclusion that it must have been that these two or these continents were once together. That's why the fossils are found on both of these continents. And so when now they started to separate, now that's how they went to different continents. And a good example, there was a freshwater reptile called Mesosaurus. And some fossils of it have been found on both South America and Africa. And the question that we need to ask ourselves is, how did it cross the ocean? And your guess is as good as mine and also that of Wigner, that these continents must have been together, and then as the tectonic plates moved far from each other, that's how now these fossils found themselves on different continents. We've added evidence which is more geographic, geologic evidence from geology, you know. Rocks made of similar materials or mountains formed at the same time are found on continents that are now far apart. With a fourth evidence, that of climate. The continents show evidence that climate changed, okay? Where fossils of tropical species found in Antarctica means it was once close the equator. These are just some of the few evidence that we have to show that it's true. We had continental drift. There are other evidences which I've highlighted, but you can continue doing more research on the same. So that was continental drift. Now we move to the second theory, which is plate tectonic theory. Plate tectonic theory. And I want you to take your time, look at what I'm showing you there. And if you're looking at the arrows show the movement of the plates either towards each other or against each other, or sometimes with those that are, you know, one going up, another one going down. Kindly take your time, and by the look of those arrows, you can tell how the plates move. Did you know that the Earth's crust is broken into many tectonic plates like a giant puzzle. These plates float are always moving slowly but powerful, and they move between 1 to 2 inches per year. It might be slowly, but it's there. There is a movement. Even right now, as we're talking, where we are, it's moving. Only that it might be so slowly that we might not feel it. But the thing is, the plates are always in motion. I'm showing you tectonic plates with many of these plates, with the African plate, South American plate, Pacific plate. There's so many of them. Kindly take your time, and you can even write down all the plates that you can see on your screen. Have a look. What do you see? Do you see the tectonic movements? Take your time and observe how the plate tectonics move. Now, as we said, they are always in motion. They're always in motion, as it's well depicted on your screen. We have several types of tectonic movements. With the divergent plate boundaries, now the two plates move away, they drift apart, they move away from each other. We've also convergence, the two plates move towards each other. With the third one, which is transformative or transform plate boundaries, and the two plates, they slip past each other. They slip past each other. There is a clear diagram showing the transform, divergent, and convergent. Take your time, look at it. The arrows are showing you the direction of movement of the plates, whether it's towards each other, against each other, or sliding. What are the results of the plate tectonic movements? One, they result to earthquakes. When plates slide past each other or they collide, they cause shaking of the ground. Two, with volcanoes. When the plates pull apart or one slides under another slide and under another plate, hot magma rises and forms volcanoes. We also have the formation of mountains. When two plates push against each other, they fall and rise to form mountains. My dear learner, I'm sure you've enjoyed the lesson. You've learned much. And for now, I say goodbye, my little geniuses. We'll continue learning more and more. Keep following, share with your friends, share with other people so that they can benefit as well. Goodbye.